Good morning and welcome to the next session of our subject Arduino based systems. In the last lecture I had just overviewed about the overall subject, and we find that the subject consists of one module on digital fundamentals, one module on operation amplifiers, there is some analog things needed, and remaining 4 modules are based on detailed discussion of Arduino. The laboratory session, which we will be starting very soon, contain the practicals about Arduino. Therefore, in order to maintain appropriate synchronism between theory and lab, what we intend to do is we would like to start with the 3rd module. Instead of moving in a sequential manner, we intend to start with the 3rd module, and that 3rd module is about the Arduino. That is, it starts with the basic concepts of Arduino. In the last lecture itself I told you that the Arduino is nothing but a microcontroller, a specific microcontroller used for simple applications having less number of pins. Is a family of that microcontrollers is named as Arduino. I am sure that at least few curious students out of you would have searched on Google for von Neumann and have tried to understand some contents of it about the computer architecture. We continue further, and from today we shall spend some time, as I had told you last time itself, that this being a somewhat very interesting subject, if we have to think deeper, then we may be required to meet for some more time. So we will be engaging some additional sessions, for which I will be circling the link. We will be having interactive sessions also. As I had already stated that I will also circulate some links of the material already available. Even that is not needed, because you can easily search on Google. Means nowadays it is no longer something exclusive thing to be told. Therefore, general information which is available is easily accessible to you. But I will try to ensure that the contents of my lecture remains still relevant, meaningful for complete understanding. In classical things which are normally available on internet, that is the standard lectures, they presume a peculiar class of teaching learning environment in which this, let us say, either it is available from some universities abroad or in IITs, where students are also expected to contribute a lot in a disciplined manner, whereas unfortunately, I presume this would be an exception for your class. Unfortunately, what we find is that much exposure of the contents is not there for our students. Therefore, yesterday I got a message that what kind of background of 11th, 12th is needed for this subject. What contents which were discussed are important. So what I have decided, that with zero background, that is a simple common sense and a general awareness of the contents, scientific contents which are there for everyone at 12th, each and every content which I describe is made understandable. So that is, I don't expect any prerequisite. Most of you may have some other kind of information which will add a value to it. Okay. So, as I said, that Arduino is a microcontroller, and microcontroller essentially is a microprocessor. So, in few sessions we shall deliberate in detail we shall, because that is very important. Maybe it is not explicitly described in our curriculum, because the problem of the, what we can say, standard educational institutes is that the curriculum is available on web to the entire world. It needs to be submitted to various authorities like AICTE, university, etc. So from that point of view, it has to be standard one. It cannot contain very minute raw details which are otherwise assumed to be known to the students, but not so. So what is the point here is that I will explain in such a manner that it is understood by the students. Sometimes, as I had already stated, I will take help of mother tongue, that is Marathi language, because what is important in the teaching learning process, learning of the contents by the student is important and not teaching of the content by the teacher. Teacher can come, talk fluently, grammatically correct, not factually wrong, and go away. So he has done teaching, but whether the students have learned or not is important. A very good classical oratory is there with the teacher. Delivery is very fine, but no understanding. It is not hitting the target. So that is beating around the bush, running on the periphery. So I want, what is the student-centric system, the learnability of the student is required from the student aid, whereas then that learnability also needs to be grown, because you are now new to professional college. Till 12th, in school days up to high school scholarship, even up to 9th, the understanding was the focus, but from 10th onwards, scoring in examination and especially CET became the focus. Against that background, now in an era of cutthroat competition, nobody can complain. Whatever happened, happened. But from now onwards, these are the years in which you have to shape your career. And from that point of view, understanding everything is important, and therefore I will try to give more thrust, more focus on that. So the ideas are very clear. The point from where we need to begin is also clear, and that is microprocessor. Microprocessor to a large extent has been a transformation. So we focus now on microprocessors. Today's world is of artificial intelligence. It is next step after microprocessor. So in the induction program I had told you about artificial intelligence. You also, each and every student, irrespective of his branch or discipline, that is whether civil, mechanical or electrical, must get himself or herself acquainted with artificial intelligence. And from, not now, but once you get comfortable, once you get well settled, you are expected to go through the details of artificial intelligence, for which the information was already given in induction program. So that is the next step. So right now we don't bother about that step, but microprocessor in itself, this is the microprocessors. Intel is having a world, there are others as well. In India also there was 650 microprocessor. Motorola is there, analog devices is there, but if we worldwide you will find that Intel in 1960s, developed microprocessors in the, what we can say, not present, there is a huge transformation, but in compact form which we say, and at least few decades were there on microprocessors evolving, they still evolve. Now the things have, within microprocessor itself there is a revolution. The things are not so easy to learn a microprocessor now. Independently for a particular chip is not required. The things have generalized and even you can develop a microprocessor. Remember, you can develop a microprocessor. So, what is speciality of this microprocessor? Remember that this microprocessor is the heart of this Arduino. The microprocessor is heart of this Arduino. That is, it is microprocessor only with some additional peripherals inside it, that is microcontroller. So what is specialty of it? Then you might be aware that, listen very carefully now, I am explaining to minute details. There was human civilization centuries back, wheel was first available, and that time, so all this scientific development is with an intention to make the human life easier. Entire scientific development is to make human life easier. Means there should not be much efforts. So in order to save efforts of human being, firstly the thing should be made smoothly happening. So wheel was one of them. And to reduce the heavy work to be done by human being, some alternative, and earlier there were other animals like bullocks, donkeys, horses, etc. Then came, so till 500-600 years back, when there was development of steam engine, IC engine and current electricity, the only way of reducing the labor of human being was to use the animals and some kind of wheel-like arrangement so that you get good efficiency. Then later what happened? With steam engine, IC engine, current electricity, that is motors, generators and motors, things got more and more progressive, and the concept of atomization was coming into picture. But all that atomization was, what we can say, dedicated work. We have to design some fixed thing for each application. Then things proceeded further and transistor was developed. We are somewhat running fast because we can't, even though I had said that we need to meet extra, in that extra meeting it is not expected that we should spend much time on something which is not so required. So transistors and then integrated circuits. So you are now well aware. If not, you can become aware by just Google search. Digital electronics, gates, then these things are in our syllabus. Adders, subtractors, multiplexers, demultiplexers, flip-flops and counters. So digital electronics got developed and that made the things further simpler. But in all these things, it was structured one, that is, we have to give some input, we obtain some output, we have to go for even using the, what we can say, digital electronics, still it was a dedicated hardware for each application. Then the computers, especially for computing, remember now that whether the word computer describes the things which it does is or not, is whether the word computer is appropriate in describing the capabilities of that or not is a different question today. But earlier, performing calculations was major aim or objective or a dream or a task which the developers were thinking in designing computer. So even computers were there even before the invention of transistor or ICs or digital chips, even in earlier part of what we can say previous century. But they were highly mechanized systems, much larger in size. Punched cards and all those things were there still. But in 1946, again, when this concept of digital ICs was not there, what is the special von Neumann? Von Neumann had conceived the idea of computer. Even in that era when there was no possibility of it getting implemented. Remember, von Neumann conceived the idea in that era when its realization was not even in dream. Forget about reality. Its realization was not even in dream. That time von Neumann thought of computer. Now, that is microprocessor, or he said it to be a central. Now, what von Neumann had thought of, I will explain each and this microprocessor is very important. Irrespective of discipline, I say it is a generalized. There is nothing like, see now, things have progressed to a large extent that there is nothing like electronics. Microprocessor is a general logical theme. Only thing is that we make use of some electronic circuitry, except that there is nothing electronics in microprocessor. Microprocessor is a very quite general subject. So what von Neumann, now there are two approaches with which we can proceed for microprocessor. Firstly, using digital circuits, how can we study deeper and deeper, perform or prepare a bigger digital circuit? Ultimately, microprocessor is a digital circuit comprised of gates and buffers. Complete microprocessor is a digital circuit which uses logic gates as basic building block. Using gates you can have all things, that is demultiplexer, flip-flop, counter, shift register, and buffer is also very important in microprocessor. So using that a tri-state buffer, those who might be having electronics at 12th might be aware of it. So logic gate is a basic building block, everything you can do using logic gate, and a tri-state buffer. Using these two things, any microprocessor can be prepared. But that will become too focused, not what we can say, not appropriate, but it is not required for the first year, which is common to all branches. So that will be becoming too detailed. We neither do have that much time, nor that is required. So we think of microprocessor from the point of view of conceptual level. So I will explain the entire microprocessor. To you by using a master-servant terminology. So, and it is like a story. Means it requires no fundamentals. I will explain you in a very systematic manner. Now listen very carefully. I will see, unless we go through minimum 2-3 sessions, you will not be able to understand it completely, but try to patiently listen till that point. What is a microprocessor? We can very effectively define microprocessor is a non-living servant. Listen very carefully. I am trying to explain it in terms of a story. Microprocessor is a non-living servant. Being non-living, it does not have the human being aspects like mood, tiredness, lethargy, etc. So I will explain to you microprocessor in a systematic manner. Let us say that master, that is yourself, maybe your parents, somebody who is working, has to go for his profession, maybe job, maybe what we can say own business, maybe studies like you. And to do all other works, there is servant. So servant is a human being. So human being does something with his hands. Human being does something with his hands. He can talk also, he can listen also, but talking, listening we don't make use of. We make use of two aspects of human being. He works using his hands. So now I'm building a story of microprocessor. So microprocessor means I will explain how things take place in case of a living servant, a servant being a human being, and then I will means the sequence of operations which take place between master and servant. Sequence of operations which take place, the interaction which takes place between master and servant in a conventional manner. We will codify, and then I will give a task to you. You should also think what kind of changes are needed if the servant is to be a non-living entity. How to achieve that is different part. What maybe now that the world is so advanced that there is hardly any scope for science fiction. Means whatever you think of is available to you. So fiction is not remained a big deal to that extent. But still, you should means what is the meaning of fiction? Means it is not required that whatever you dream should be realizable. Something which is not realizable is also allowed. Maybe after somebody else or you only after some time will realize it. So what is the discussion of today's, from now onwards, the discussion is beginning in a structured form. The discussion is the master-servant communication in an effective manner, listed appropriately so that you should be able to define it if servant is a non-living entity. Okay, so we define. So what servant can do? Servant, that is, the servant is now actually a human being right now, or a microprocessor system. A microprocessor system. So this human being is living entity, this is non-living entity. So what servant capabilities are there? He can read, he can write, or he can listen, he can talk, right? Similar to reading, he can read generally, or he can see. Seeing and reading is different. Reading means only some letters, but he can see if the lamp is on or not. So he can see and he can control or actuate or control. That is, he can put the switch on and off. He can put the switch on and off. Maybe those who are knowing staircase lighting. In case of staircase lighting, means the arrangement is whether down is on or up is on, depends upon what is the position of the other switch. So he can control the switch, he can watch whether the lamp is on or off, right? So read, write, listen, talk, see, or means he does it using eyes, he does it using hands, he does it using ears, he does it using mouth, he does it using eyes, he does it using hands, right? So a living servant can read and write, he can talk and listen, he can see and actuate. So these are using eyes and ear. These are its input ports or input devices, we can say, and using mouth and hand output devices. Now we see, this is the just example I am giving. We are not at all arguing that this should be there. Just the only means there is no, what we can say, intention of demeaning a servant. Just to explain, since it is easier for understanding, we are using this example. Also, this servant is not expected to be smart beyond an extent. Remember, servant is not expected to be smart. Servant is not smart means in the sense that servant should not be able to decide anything on his own. Everything should be instructed. ज्याला मराठीमध्ये सांगकाम्या असं एक नाव दिलेलं आहे. तर सांगकाम्या हे नाव म्हणजे मायक्रोप्रोसेसर. मायक्रोप्रोसेसर एकाच शब्दात सांगकाम्या. त्याला स्वतःहून काही सुद्धा ठरवता येत नाही. सर्व अत्यंत व्यवस्थितपणे सांगितलं असतं आणि एखादा सांगकाम्या नोकर आहे तर त्या सांगकाम्या नोकराकडून व्यवस्थित काम करून घेण्याकरता मालकाला काय काय करून ठेवावं लागतं. दॅट इज द प्रोटोकॉल ऑफ कम्युनिकेशन. सो सर्वंट इज एक्सपेक्टेड टू बी नॉट स्मार्ट अँड देन थिंग विल प्रोसीड फर्दर. सो right now this is the part 1 of today's session. In the next lecture, which you should immediately watch, in part 2 we will exactly codify the activity.